Right. Our next speaker is Roisin Kierstead on the impacts of forest cover and crop field margins to wild bees and wasps.
Hey, hi everyone. My name is Roisin, and today I'm going to talk about a bit of my master's research, which is on the effects of forest cover on nesting bees and wasps in Ottawa crop field margins. So I'm a master's student at the University of Ottawa, and my supervisors are Dr. Jessica Forrest at the University of Ottawa, and also Dr. Alana Nayakaitis-Lewis with Environment and Climate Change Canada. So again, the topic of my talk is the effects of forest cover on nesting of bees and wasps in Ottawa crop field margins. So I'll just give a little bit of background about forest cover and crop field margins. So extreme temperatures are harmful to species because they surpass their physiological limits and they can cause death or disrupt reproduction. So forests can buffer temperatures by creating cooler and also create cooler and more stable microclimates within. And in a global review of studies by Dufresne et al., they found that microclimate studies in all found that temperatures underneath forest cover were on average lower, and also maximum temperatures were lower and minimum temperatures were higher. So they concluded that forest microclimates are doing two things. They're dampening variation of temperature, and they're also lowering overall temperatures. And forests, small patches of forest even could be important and have this effect, especially in areas where there's not many other thermal buffering attributes, like in crop fields, for example. So crop fields, especially the ones around Ottawa where I'm studying, are flat, so they have low topography, and they have few bodies of water. And so those small patches of forest that do exist there could be extra beneficial. So wild bees and wasps occur in crop fields, and they also suffer the effects of extreme temperatures. So specifically, bees can experience, when they're developing and they're exposed to hot temperatures, they can experience smaller adult body size, and they can also have premature death. We know little, however, of how bees or wasps can benefit from the thermal buffering attributes of forests. We do know that many bees are in decline, and habitat loss is a primary driver of this. And so as forests are converted to farmland and as climate change increases, there's an increasing need to look at the benefits of forest habitat and the thermal buffering attributes that it may benefit bees and wasps. And so that brings me to the objective of my research, which is how is forest cover and crop field margins influencing thermal variation, and how are both forest cover and thermal variation influencing bees and wasps in crop field margins. For today, however, I'm going to talk about just one part of this triangle, which is how does forest cover and field margins influence bee and wasp nesting? And so when I say nesting, I'm referring to things like what species are nesting in the crop field margins and how many nests are different groups of bees and wasps making. So to get started, I needed to select some sites. And so I had access to a large collection of sites that Environment Climate Change Canada has been working with for a number of years. And so before I got started, some people at ECCC had taken satellite images of crop fields around Ottawa and analyzed the percent forest cover using the satellite images. And so I ended up creating a collection of sites, 17 sites that has between 1 to 83% landscape scale forest cover. But landscape scale forest cover was not the only measure that I was interested in. I also have at each of my sites 2 different distinct types of margins. I have a forested margin and an open margin. And so these are some visual examples. On the left is a forested margin, so it has a dense covering of trees and shrubs. And on the right was a typical open margin, which is completely different. I wanted them to be free of trees and shrubs. And so to recap, I have these 2 different metrics. There are the 17 sites with a range of landscape scale forest cover, and each of those sites had an open and forested margin. So at each of my margins within sites, I installed wooden stakes like this one here. And on the stake, I have nesting blocks. And so the equipment above this wooden block is for recording temperature. The nesting blocks are essentially just wooden blocks with holes drilled into them. And each of them has a straw within it. And so bees and wasps are able to nest in those straws. On the right, you can see that I've pulled out one of those straws, And essentially, I would return to each of my margins throughout the year, to each of my trap nesting blocks, look at these straws and record the presence of new nests and also identify the builder of that nest. And so obviously it's more difficult to ID who built the nest if you don't see the actual mother bee or wasp doing the building. But there are some things that you can look at, such as the contents of the nest. For example, it's only bees that will provision their nest with pollen. So if you see presence of that, that will help. And also the materials that are used to build nests. So leafcutter bees, as they're so called, you cut out circles of leaves, and that's what they use to seal off their nests. So who did I find in my, oh, sorry, to recap, I have numerous species that can nest in my trap net, in my nesting blocks, and I have a number of maximum straws or nests. So who did I find in my nesting blocks? So I had a lot of different types of wasps and bees, but there were 4 main groups, and those were the Osmia species, potter wasps, megachile species, and Haleus. And so all 4 of these are cavity nesting bees and wasps, and they take pretty readily to artificial nesting flocks like mine. So next, I looked at those same 4 taxa, and I looked at the number of nests divided by margin type. And so you can see on the y-axis, I have number of nests, and then again, x-axis is field margin. So the red is forested and blue is open margins. And what I found was that only 2 of the different groups are seen to be affected significantly by margin type. So potter wasps and megachile bees. However, they're being affected in opposite ways. So for the potter wasps, it was the forested margins that had more potter wasp nests. However, for megachile, it was the open margins that had more nests. I think that this result can be explained by the foraging requirements of each of these groups because they're quite different. For megachile bees, megachile are bees, so they provision their nests with pollen. And so in open margins, there's more sunshine and potentially more floral resources, and it's a more fruitful place for a megachile. And we know that foraging effort is directly connected to reproductive output in bees. So that could explain why it is the open margins that have more megachile nests. However, potter wasps, they do not provision their nests with pollen. Instead, they provision them with prey items like caterpillars or beetle larvae. And those are things that potter wasps often forage for on trees, so on shrubs or trees, and that's because those larvae are eating the leaves of trees. And so it's not surprising to me that there's more nests of potter wasps in forested areas as opposed to open margins. So next, if you recall, I had another measure of forest cover, and that was the landscape scale forest cover. So I looked at the number of nests again by taxa, but instead with this measure of forest cover. And what I found was that landscape scale forest cover had no effect on the number of nests made by all of my main bee groups. So Osmia species, megachile species, and Haleus had no significant relationship with that level of forest cover. However, this was not true for the potter wasps. Instead, I found a significant positive relationship with percent forest cover and the number of potter wasp nests. And again, I think that the foraging requirements of potter wasps versus my other bee groups are a good explanation for this result, or a possible explanation for this result. So again, potter wasps are looking for prey like beetle larvae and caterpillars that they can find munching on leaves. And so sites that have more forest cover would presumably be better for the number of nests that potter wasps make. So next, I looked at the number of species per margin in trap nest. And so this was my measure of diversity at looking at different trap nests or nesting blocks. And so what I found was that between forested margins and open margins, the number of species was higher in open margins. I'm not entirely sure if this result is based solely on the margin type. I think it also could be due to something that is co-varying with margin type. So as I mentioned before, open margins have more sunshine and probably have a lot more floral resources and a more diverse assemblage of flowering plants. That can be conducive to attracting more bees and more wasps, and that could be an explanation as to why there are more species I see in open versus forested margins. I did thorough surveys of floral cover and floral resources at all of my margins in the summer. I just haven't had a chance to analyze this data yet. So what's next for me? Well, I have a lot of straws or nests that I can now collect and look at each individual offspring within and assess the survival of all those offspring. And on top of that, I've been recording temperature data all throughout this year. And so I'm eager to go back to this temperature data and to look at how forest cover in the margins is influencing thermal variation, and then how that's influencing bees and wasps, their nesting, as well as their diversity and their abundance between margins. So on the topic of temperature data, I did record temperature data in 2022 throughout that summer. And I did have a chance to analyze those data. And so this is showing the mean daily temperature range on the y-axis. And that's a measure that I decided to use as a way of looking at thermal variation. And so there's landscape scale forest cover on the x-axis. And what I found was that landscape scale forest cover had no effect on the amount of thermal variation, but margin scale forest cover, so the type of margin, did have an effect. And open margins generally had more thermal variation than forested ones. So this finding was valuable to me, and I'm keeping it in mind, and I'm eager to look at the 2023 temperature data that I collected. So that's all that I have, and I have tons of people to thank. Thank you to those that supported and funded this work. And thank you for listening. I'd be happy to take any of your questions.